We are turning on the recording, and we do intend to release this recording. So if that's not something you're super happy with, then you might want to sign off and check out the recording afterward. But hopefully it won't be too big a deal. I'm going to go ahead and start the slides. Share my screen. And there we go. Okay, so welcome to our orientation today. This is actually session A of a two-session series. We realized that we wanted to do an orientation and there was just way too much stuff to fit into one orientation. So this is the session A orientation. And you know, the target audience here is really anyone new to N3C, especially for those with sort of research ideas and who are curious about the data, you know, whether or not the data will answer the kinds of questions that I have. How do I get access, stuff like that. Session B, which will happen next week at the same time, covers more technical topics, which are both useful for sort of people who are new to data analysis in general, but also really useful for data scientists who have a lot of experience because the tools in the enclave are quite different than most data scientists are useful or are used to. Before I go too much further, let me see if I can make this, oopsie, full screen. There we go. So there's a lot of N3C knowledge distributed in a lot of different areas. And so I wanted to really acknowledge and thank the folks who came together to help put this presentation together. These subject matter experts are really critical to N3C in general, but also especially this particular presentation. So Devera, Emily, Kristen, Alex, and then we do have some subject matter experts on the line in the Q&A. So if you have questions, please use the Q&A feature. That way we can sort of keep track of which questions have been answered and asked. And Richard Moffat here and Devera, as well as some others, are available to be on the Q&A and answer some of those questions. And Sean O'Neill down here at Oregon State University, that is me. Okay, so I want to talk just briefly a little bit about the problem that N3C is addressing. You know, the US has no central data repository, right? We don't even have a standard data model or format. Different organizations use different systems. Generally, each organization has its own sort of data warehouse where it stores its own data for its internal purposes and needs. And these are often unique. But you know, some progress has been made by research consortia networks implementing what are known as common data models or CDMs. These are agreed upon methods of data organization, right? And they're sort of the secondary data sets generated from the original electronic medical records source data or the EMR data. And these really help the research enterprise because researchers then can sort of target a particular data model when they're answering their questions. Even so, several common CDMs are in use nationwide. Some institutions even participate in multiple networks. And so a particular institution might have a version of its data in its original data warehouse, one in the pCoreNet model, and then maybe one in the I2V2 model. For the most part, researchers, in order to analyze this data, have needed to, you know, first identify or associate with one of these networks, right? So maybe I'll join up with the pCoreNet folks and then access to the data there, but I don't really get access to the data. What I do is I can generate a question that can be asked against, you know, sort of pCoreNet formatted data. And then I can distribute a query out to those pCoreNet institutions so that they can run my query on their data. And then what I get back is sort of like a collection of answers that can be used if I want to ask questions about EMR data from multiple sites. This is sort of a federated model wherein, you know, the researcher doesn't get direct access to the data. And what this does is it kind of precludes some techniques like exploratory data analysis, and it precludes some machine learning techniques. So it's not the ideal. To solve this, what N3C is doing is we're recruiting data partners around the country to collect COVID-related data into a single unified database and data model, known as OMOP in this case. This is tricky because the source common data models are quite different, and even for a particular source model like pCoreNet, there can be differences between the sites because each site is sort of like creating that common data model from its own source data, which might not be the same as every other site. This process is known as harmonization. And there's a really amazing team of folks at N3C who work closely with the data partners to make it happen. And since this is harmonization from a common data model, it's sort of a unification of unifications, as it were, for a tertiary data use. So the primary data use are those original source data warehouses. The secondary data use are the research network common data models. And then N3C is grabbing data from those common data models in a tertiary fashion, putting them into one big database and data model. It's also, this is one of the very first instances, at least that I'm aware of a US-wide centralized repository for health data. And it's really enabled by some very cool cloud technology, which we'll see a little bit more about later on. The target data model that we're going to deal with is OMOP, and you'll hear a lot about it in N3C because understanding OMOP is a key to making sense of a lot of the data. But it is a learning curve for many. Not a whole lot of people are coming in with OMOP experience, so that's something to be aware of as you get started with N3C. Now, because this is sensitive data, we can't just sort of redistribute it to researchers. Rather, we keep it under lock and key in this highly secure cloud enclave, as it were, to which we grant access to research teams with really particular access controls. This is another bit of a learning curve because there are actually several steps involved in getting access to these millions of patient record data in this secure enclave. Lastly, because the data do live in the cloud, the tools to analyze it must be accessible via the browser as well. So the good news is that we do have the usual suspects like R and Python and SQL and some surprisingly powerful sort of GUI-based analysis tools. But as a matter of legality, we have to be really cautious of data protection. So even within the enclave, literally every bit of data and code and all the actions are tracked. So the interface that we deal with Python and R and all these other things is quite different than most data scientists are familiar with. So if you're coming in with experience with something like RStudio or with Jupyter Notebooks, the interface that you'll experience inside of the data enclave is quite different. And this is sort of yet another learning curve that folks with N3C have to deal with. So if all of those learning curves and new things sound daunting, worry not. We've got a lot of resources to help you get started, including our little orientation here today. And the N3C community is really, really friendly and helpful. And that's something that we really work hard to generate as part of N3C. So what's actually in the data? So this is a screenshot of a dashboard from a couple of weeks ago. As of recently, there were 39 sort of data partners contributing data on 2.7 million patients, about 500,000 or so of whom were COVID positive at some point. Notice that there's a little star here. It turns out that something even as simple as defining what COVID positive means isn't straightforward. And with the variety of PCR tests, antibody tests, antigen tests, diagnosis codes, and so on and so forth, there are lots of different criteria that you could potentially use. And so this little dashboard comes with a disclaimer down at the bottom that describes that. Data are pulled not for all patients at every data partner. Rather, what we try and pull are all the COVID positive patients by this definition that we've come up with, as well as twice as many demographically matched controls. I put controls here in quotes because it's worth keeping in mind, even though we're trying to get as comprehensive data as we can, these are not really random population samples, right? There's selection bias is something you're going to want to think about as you take a look at this data, even though we're trying very, very hard to make it as broad and comprehensive as possible. You may notice here that these numbers aren't in this 2-to-1 ratio. And that's because there are not all sites have actually updated to the latest definition of the data pool where this 2-to-1 match control thing was implemented. And really, I'm just mentioning this because I want to highlight this dynamic nature of the N3C data. It can and does change over time as the pandemic unfolds. But all older versions of the data are kept for reproducible research, right? And so in fact, data are contained in releases. And this dashboard is just showing the summary for the most recent release. Releases are refreshed about once per week. And generally, your analyses will be working against the latest release. You can always reference an earlier release to sort of pin your analysis to a point in time, at least as far as the N3C data is concerned. For the patients identified as part of a particular release, we don't grab their entire history either, but we do grab everything going back to January 2018 for a pretty recent historical snapshot. The second row of this dashboard shows summaries of a few of the tables defined by that OMOP common data model. You can see we've got lots of good, yummy data hanging around in the enclave waiting for analysis. So even that, however, is not the whole story. Not all researchers will need every detail of every patient. So we've set up 3 levels, quote unquote, of data inside the enclave with different access requirements. I'm going to apologize here for the small text on this particular slide. This is from a governance page, and I didn't have the liberty to paraphrase it. In any case, the most comprehensive data are the level 3, aka the limited data set or LDS data. This is the sort of rawest data available, and it includes 2 protected health or PHI information fields defined by HIPAA. Those are the accurate dates of service and the patient zip codes. But it does include many other identifiable information like names or birth dates and stuff like that. Level 2 data or de-identified data are the same thing, except these dates of service are randomly shifted for added patient protection, and only the first 3 digits of zip codes are revealed. There's good news here, though, that the date shifts are random, but they're random per patient. So it's still possible to say something like, I need to identify all the patients who've taken a given drug within 10 days of a COVID positive lab result. You can easily identify those particular patients. You won't necessarily know at what point, in 2020 that happened, but you'll know that that particular drug happened within a certain amount of time of a particular lab result. And then lastly, there's level 1 data, also known as synthetic data, and these are a bit different. Rather than actual patient data, they contain data derived via a statistical model of certain subsets of the level 3 data. And while the level 2 and level 3 data are in that OMOP format, the synthetic data currently are in a simpler single table format that's pre-processed depending on the information of interest that you want in that particular synthetic data. These 3 levels are available to different classes of researchers. So sort of here reading from the top to the bottom, level 3 data is only available to those, Level 3 data is only available to those at US-based research institutions, whereas level 2 data is also available to researchers from foreign institutions. And then lastly, the synthetic data are available to pretty much everyone, including citizen scientists, which is to say, those without an affiliation with a research institution. Where these 3 levels of data really differ are in their access requirements. So even the level 1 data requires some access steps, including, you have to register with N3C, you have to get an enclave account or get access to the enclave after you register. And then finally, you need to get a data use request or DUR approved, which is sort of like step 3 here. To get that enclave account, you'll need to be covered by a legally binding data usage agreement or DUA. And then to complete the request, you'll need to complete some online IT security training offered by NIH. So as I mentioned, there's quite a number of hoops that you need to jump through in order to get access to the data. But once you've done this, you'll have access to quite a different set of data sets. The level 2 data has basically the same requirements, except researchers also need to have completed the human subjects research protection training, often offered by a program like CITI at particular research institutions. And then lastly, because the level 3 data do contain protected health information, completing the request also requires review by your local IRB and submitting their determination letter. So remember that the date shifting for level 2 is per patient. So the level 3 data is only really needed if you need detailed location or dates of the year sort of information for your analyses. And when you do fill out your DUR, you'll have a chance to sort of justify the level that you're requesting for the project that you're going to be working on. Whew, okay, so those are the three levels of data, the information in them, and the who's eligible, and the sort of various things you have to do to get access to it. Mostly in this orientation, we're going to talk about the level 2 and the level 3 data, but before we go there, I wanted to give a quick summary of some of that synthetic data. So this is actually a screenshot of a synthetic data table, which I actually got special permission to show you. Generally, screenshotting row level N3C data, especially if you need a DUR to access it, it's a no-no. So keep that in mind, you know, as you're working through your various presentations or working in the enclave. We don't want folks to take any kind of screenshots and share them. What's interesting about this table is that it's created with a specific question in mind. In this particular case, evaluating COVID along social factors like income and poverty. And so because the synthetic data is generated with a specific question in mind, they tend to be associated with what are known as release notes, which describe the statistical model that generated those data. So for in this case, the statistical model isn't built from all the level 3 data, just some of the particular columns of interest which have been described in the release notes. That synthetic generation process is actually handled by a company called MDClone. Ours is Sheffy, I think I saw on the line, is affiliated with them and is available to answer some questions. And they've kindly provided some links here describing sort of how the process works. You might be wondering if the process sort of accurately reflects the original data for N3C. And don't worry, there's actually an N3C group of folks known as the synthetic validation team who are working on exactly that question, seeing whether research results that are resulting from the synthetic data match up to the results that are generated from the original level 3 data. All right, so we're in sort of a boring part of this presentation where we're talking about all the regulations and the processes and everything else. So let's finish that off before we get back to talking about the data. Let's dig a little bit into the DUA and DUR business because it does trip quite a number of folks up. The data use agreement, or DUA, outlines sort of the do's and the don'ts. You do need to read it, but it includes stuff like, you know, this data is only for COVID-related research. You mustn't try and re-identify patients or share any data. And oh yeah, your actions inside the enclave are being logged. And there's a number of other important things in the data usage agreement as well, so you should take a look at it. The best way to sign this data usage agreement is actually to have your organization or institution sign it on behalf of everyone there. N3C is happy to work with organizations to get this done, and there are over 150 who've done this so far. And the link shown here actually lists them. So it might well be that you are already covered by a DUA if your home institution actually shows up in this particular list. Now, for those citizen scientists who don't have an organization to sign for them, they can sign the DUA themselves directly with NCATS, the National Center for Advancing Translational Sciences. And we do have a few folks who have done this. And if this is something that's interesting to you, reach out to us and we will see if we can help you through that process. So at the end of the day, getting access to this enclave where the data is stored requires registering with N3C, after which someone at N3C will confirm that you are indeed covered by a DUA. That will allow you to log into the enclave, and you should get an email with some info about logging in, or you can head directly to the enclave at unite.nih.gov. However, although the 3 levels of data are stored in the enclave, getting access to the enclave doesn't automatically give access to those data levels. Instead, the way it works is research projects, which exist in the enclave, and you can basically think of as folders, get access to the data, and that access is configured by administration associated with N3C. Users then get access to those particular projects. But getting access to a project or creating a new project and then getting access to it requires filling out the data use request form, which is done inside the enclave. So you can think of each project as being associated with a single DUR, which specifies, you know, the stuff like what level of data is being requested, why that particular level of data is being requested, and all the researchers then sign on to the same DUR for a given project. These DURs are reviewed by a data access committee, or DAC, and once approved, that particular individual person is then granted access to the research project, which is granted access to the data. So with all of that in mind, we do assume you'll want to start playing with the data and tools as soon as you can log into the Enclave. Logging into the Enclave is a lot easier to do than actually getting access to the data because of the data use request that's between those two steps. So we've included some publicly available OMOP formatted learning data, which isn't locked down in any way. The name of that learning data is SynPUF, short for Synthetic Public Use Files, which isn't really to be confused with the level 1 synthetic data, which is based on the LDS data. This SynPUF learning data is a much older data set that was generated purely for learning purposes. So I think it's worth taking a very brief break right here and just seeing if there's anything important coming up in chat or live that we want to address. Devera, Richard, Alex, Trisha, anybody?
Question's been pretty quiet so far.
Okay. I'm flying through this, I think, a little bit faster than I did on the first iteration. So if anyone wants to jump in with a quick question for us to answer, happy to do that. We also only have a handful of participants this time, so if we wanted to turn on microphone access for everybody, I think that would be okay. Going once, going twice, 3 times sold. Okay, so let's take a look at the Enclave. That's where all the good stuff is, and everybody likes to see the technical side of things. So this is the Enclave homepage. This is what you'll see when you first log into the Enclave. And look down here, that's our fancy dashboard that we mentioned earlier. There are a few things here on the Enclave homepage that I do want to highlight while we're here. First is N3C has quite a number of different ways to get help. Some of these help avenues are inside the Enclave. So if you have a question about patient data or code, and that question should stay inside the Enclave because it is about patient data, then you should ask for help inside the Enclave. And you can do that by going to the support and contact link on the Enclave homepage, or you can go directly down to the help and support menu in the lower left. There are, however, external to the Enclave help avenues, and these are great for pretty much all other questions like, hey, I can't get access, I can't seem to log in, I can't get on the Slack, you know, whatever it is. There are external to the Enclave help avenues, and those are also listed under support and contact here, or you can go directly over to the external to the Enclave help area here at the help desk. And this is really great, like I said, for pretty much anything that doesn't pertain especially to the data or the code of the Enclave. So all those organizational process questions are great to ask at the ticket system that's linked to right here. Second, I want to highlight the training section of the Enclave homepage. I won't show the page there, but the link is up here at the top, and that links to lots of resources, including some N3C specific training modules and videos and things. So be sure to check these out. There's information in the training section that is really only available there, and that you'll want to know in order to be comfortable with analyzing N3C data, as well as don't forget our session B orientation, which is next week. So we mentioned that DUR process. These 3 buttons here on the homepage deal with DURs and project access. There's actually quite a lot about them that we don't have time for here in this orientation. So check out the Enclave organization training module in the training section of the Enclave. And you can also check that out outside of the Enclave in the tutorial section of the CD2H site under Enclave organization. So there's a section about halfway through that video that talks about, you know, what the DUR process looks like, whether you're a principal investigator or sort of an analyst. And it'll walk you through the process of doing that DUR. While we're here, notice over on the left navigation bar, there are various tools for analysis, and the projects and file link is for navigating to, you guessed it, projects and files and data. So everybody likes screenshots. Here are a few more. This shows the projects list under the projects and files button. So if I were to click here, we sort of initially see the projects tab is opened. Most of these are research projects, the ones that are prefixed with RP, and they are associated with a DUR. So this is a research project folder that has an associated DUR that someone has spun up as part of N3C. Over here on the right, you'll see some buttons that say request access. Ignore those, they don't work. They're sort of like a vestigial leftover of the interface. Remember that in order to access a project, you have to fill out the DUR, which means that you'll need to go there from the home page and those three big blue buttons. These three buttons are sort of shown here, but they aren't hooked into that DUR process, and so they're just sort of a red herring. So still under that projects and files link, we can check out the data catalog tab. The data catalog contains data collections, which are basically read-only sets of data and files conveniently organized for easy finding. So data natively lives in projects, but projects can have all kinds of stuff in them. They can get quite messy. The data catalog is a great way to sort of say, here are some important subsets of things that exist in projects that lots of people will want to have access to. The different levels of data can be browsed here. So for example, if you have access to that level 2 de-identified data, you'll see that show up here, as well as collections of things like dashboards and applications that can help with analysis under that particular data catalog. Moving on to take a look at some analysis tools. This is a screenshot of a Contour, which is a graphical user interface for basic data manipulation, like joining, table filtering, data, simple visualizations. And although it's graphical and hardcore coders might turn up their nose a little bit, there are some good reasons to get familiar with this particular tool. First, it knows how to efficiently work with 3 billion rows of data automatically. So the coders in our audience will eventually get familiar with code workbooks, which I'm going to mention next. But you'll find that analyzing these large data sets is going to require getting familiar with Apache Spark, which is a high-performance distributed computing framework. And this Contour tool automatically works with Apache Spark in a relatively seamless way. The other thing I like about Contour is it can do pretty much everything SQL can do, including date arithmetic and grouping and aggregations and stuff of that nature. And finally, the resulting sort of filtered, processed, and joined data can be exported from this particular tool as a table or a number of tables. And then you can pick up those, filtered, joined, processed data and analyze them with R, Python, and other tools in the enclave. So then there are code workbooks. So this is a sort of hybrid interface for writing data analysis code. Each node here is either an imported data table or a function in like R, or Python, or SQL that takes some tables as input and spits a table out as output. And so you kind of create this flow of data tables throughout this computation graph. Some of the elements can also produce plots and graphics along the way. And there are a bunch of other tools here that we don't really have time for, including reports, where you can embed graphics from code workbooks or Contour or other tools. There's a spreadsheet-like tool known as Fusion, and there are several other tools, but the Contour and code workbooks are probably the big two that you'll eventually get familiar with if you're going to do data analysis inside the enclave. As a quick break here, how's it going? Anybody have any live questions or things that are worth chatting about?
Sean, I would recommend if you do have a question, just raise your hand. At the lower part of the screen, there's a raise hand and we'll unmute you.
All right, going once, going twice.
Oh, we've got, oh no, it went away. Never mind.
Going 3 times, going 4 times. All right. So let's get back into it. And we'll get back to some abstract stuff here. So we mentioned that OMOP is a really big part of N3C, and it's the data format for the level 2 and the level 3 data. But what is OMOP? I'm afraid that I'm not really the best subject matter expert about this, but I'm going to sort of see what I can do. And we do have some excellent subject matter experts on the line who can answer questions about it. So OMOP was the result of the Observational Medical Outcomes Partnership. And this is a project to do basically exactly what N3C has a need for, which is to collect disparate health data into a single unified data set. I believe actually that the OMOP project had goals far beyond just creating a single data model, but the data model itself was really something that people picked up upon. The original project ended in 2013, and since then, this core data model has been stewarded by the Observational Health Data Sciences and Informatics Collaborative, also known as OHDSI, pronounced Odyssey. So if you're already familiar with other electronic health record systems, but not OMOP, it might take a little bit of getting used to. OMOP is designed with data analysis in mind, whereas many data systems are designed for internal purposes like billing. And Odyssey and OMOP do try to stick to a philosophy of protecting patient privacy wherever possible. So for the most part, OMOP as a consortium discourages, keeping patient birthdays and names and stuff like that, unless it's warranted, and those exceptions do happen. So the data are stored in tables and also known as domains, which is kind of like a database lingo kind of thing. And OMOP tries to be a person-centric model, meaning each row generally, where possible, is associated with a person and whenever possible, a date. So we want to know, what happened to who and when, and that's what's generally stored in the data tables. So here's a little example of data from the drug exposure table in the SynPuff learning data. Notice that there's a column for person ID, which relates to another table with the details about that particular person, person number 4, and a drug concept ID. This is an identifier indicating which specific drug this particular record happens to be about. Another column actually shows the drug name in human readable form. It's not shown in this particular screenshot, but this numeric identifier is much more useful, as we'll see in a moment. And then we have information about, the drug exposure start date, drug exposure end date, and so on. So OMOP is designed to ingest data from a lot of disparate systems, but the OMOP folks didn't feel like they needed to reinvent any wheels or come up with brand new terminology. Instead, OMOP reuses the terms from source systems like SNOMED. So a lot of the terms that you'll find in OMOP are in fact SNOMED terms or RX norm terms, or from terms from a number of different systems. Every term, though, even though it has a code in the original source vocabulary, is also given a unique OMOP specific ID, and that's known as its concept ID. And that concept ID is called a concept ID whether you're talking about a drug or a procedure or a disease diagnosis or whatever it is. To keep things manageable, the original data is kept in the records for provenance, but those terms are mapped to a smaller set of terms identified by OMOP as a standard set that are useful for analysis. After all, there might be 50 different codes for pneumonia in the world, but we only really need one to do our data analysis. OMOP also defines, and this is a huge amount of work by a very large community, a hierarchy of relationships between the terms that are identified as standards. So this lets us know, for example, there's a table that says that Proquin XR has an ingredient of ciprofloxacin 500 milligrams. And then in that same table, there's information indicating that that ciprofloxacin 500 milligrams is an antibiotic. And what this allows us to do is to use this hierarchy to define a concept set and collect data records of interest. So we could say, for example, hey, I need to know a list of all of the concept IDs that are having ingredients of ciprofloxacin of any particular dosage, or all of the different concept IDs that are antibiotics. And you can build fairly sophisticated sets of records using this hierarchy. So you could say, I need to know all antibiotics except for things containing ciprofloxacin or something of that nature. And these are then what you'll end up finding in those original data tables. This can be tricky. So fortunately, there are tools developed by Odyssey and even a few N3C specific ones for working with OMOP data. You can find some details in the training portal of the Enclave in the Intro to OMOP and Contour module, where it actually goes into developing a concept set and then using it to analyze some of the SynPuff learning data in that Contour tool that I briefly showed a screenshot of. Here's an example of an N3C specific tool for working with concept sets. You can browse around concept sets defined by others, and there are other tools to help you define and publish your own concept sets. N3C cares a lot about community-driven reproducible research. So these tools also include workflows for getting expert review and publishing these important, sort of research artifacts. So for example, someone might decide to develop a new concept set to include all of the different kinds of glucose measurements. They'll use it in their analysis, and then they can sort of submit it for review, and then subject matter experts in those particular terms, and OMOP will take a look at the concept set, make sure it doesn't miss anything important, make sure it doesn't accidentally include anything it shouldn't, and it will go through a review process. And eventually, when the relevant research is published, the concept set itself can also be made public. And this also gives N3C an opportunity to reuse important concept sets across a lot of different projects. So that's sort of OMOP in a nutshell. There's a ton more information out there, and there's a lot to know about OMOP that you'll learn over time. The Book of Odyssey is an interesting read about OMOP and Odyssey, including the history of the project. Eden Academy has video-based courses you can peruse. They're fairly comprehensive, but I do recommend them. They're a great way to get to know OMOP and the related tooling. And there are other tutorials available from the Odyssey Consortium as well. And then I often go looking for this particular link here, which describes the columns in the various OMOP data tables. You might find it handy as well. Alrighty. Quick pause for raise handy questions or anything we think we should mention live.
There are no questions being put into the Q&A right now.
It's got to have something.
I know this is a very quiet group. How about if we take a moment, and if anybody does have a question, we can take it. Just raise your hand and we'll open your mic.
Okay.
Okay, nothing.
All right. So that's a little bit about OMOP generally. But there's OMOP generally, and then there's OMOP as used by N3C, right? Because N3C is using OMOP to bring in data from all of these different data partners who have different source common data models that the data are coming in from. And this is where it gets complicated, because harmonizing data from these different sources is really complicated. The team working on that part of the pipeline do run into things, and they need to deal with them. There are missing data that come from some sites. Some sites just don't have this particular kind of data or that particular kind of data. Differing units, the occasional messy data, things of that nature. And the harmonization team, their job is to sort of make sure that all the data fit into this one big single database. And these folks work really hard to put together the best comprehensive data pipeline that they can, and that includes a rather lengthy ingestion process, as well as data quality checks and expert review that go in as data are added to the collection. Even so, some things are just difficult by virtue of the differences in these source data models. Death data is a really great example. OMOP supports and even technically requires death dates and causes, right? But other models that we're sourcing the data from don't necessarily. Some require death dates, some don't. Some support cause of death information, some don't. So death data in the enclave in particular is a little bit spotty. Then there are things like defining COVID positive. There are many different PCR tests and antibody tests, and antigen tests. And when recording the results, different systems use different codes which need to be considered. Some of them aren't even that definitive, like coded as presumed positive or presumed negative. Then, of course, there is the ICD-10 code for COVID-19, U07.1, but even that wasn't used widely at the start of the pandemic. And so depending on how you want to identify your quote unquote COVID positive people, there can be a little bit of work involved in figuring that out and working with Enclave tools to do that effectively. Fortunately, we do have some tools in the Enclave that help folks do this because we've already got sort of concept sets that define the various lab tests and some concept sets that define, sort of elevated, high, and present, and those different ways to encode the data, and some tools that make use of those concept sets to identify people with COVID. So this is an interesting slide from a recent symposium on the N3C data. Prior to the symposium, they did a quick straw poll of some researchers and some data partners to see what kinds of data were a priority for researchers and how hard those data are to collect from the data partners. The results are shown here, and mostly it's worth noting that some things are easy and some things are hard. Sometimes they're hard because the data are not consistently acquired or stored in the common data model that we're sourcing from. And sometimes they're hard because in OMOP, it's just kind of hard to identify all the different ways that you can talk about a particular thing. I happen to know from experience that sort of looking for patients who are pregnant is a little bit different, for example, because there's all kinds of ways that pregnancy can get encoded in the data and in OMOP, whether you're talking about a first trimester visit, a third trimester visit, lots and lots of different things. So when working with the data, it can be very handy to see how your results break down across the different data partners. And although we don't share which data comes from which particular data partner, you can still group data by data partner because every table has a data partner ID column. So you'll know for every single record which data partner it came from in terms of that ID. So the harmonization team keeps a log of known persistent issues with the data that you should know about. And it's not just related to death and other things of that nature. You should probably go take a look at the data issues that are noted here at this link, and it requires Enclave access to get at that. And finally, if you do find something strange in the data that you're not entirely sure is intentional or not, be sure to flag it. You can report issues or questions about the data inside the Enclave under the Help and Support menu in the lower left. So if you say, oh man, I noticed that site 896 happens to have all null values in this particular column or something strange like that, you can go here, report an issue, and there's a segment for a data issue, and then that will cause somebody to take a look at that and make sure that it's known and flagged and potentially fixed if it needs to be. All right, so to wrap up, we've talked a lot about data, but the N3C is really a lot more than that. It's a pretty vibrant community. There are a lot of people, over 1,200 registered N3Cers, almost 1,000 of whom have access to the data enclave. There are over 120 research projects covered by DURs right now, and over 150 organizations have signed data usage agreements on behalf of the folks at those organizations. I think right now there are around 39 or 40 data partners with data in the enclave, but there are actually over 75 data partners who signed the data transfer agreement. So lots and lots of data is still on the way. We can expect this data set to continue to grow over time. One thing I should probably add to this orientation is that currently the data is a little bit geographically not equally distributed. So we have a lot more data, for example, from the southeastern United States, whereas like data from West Coast institutions is still coming on board. We do a lot of communication at N3C. Slack is quite active with over 30 channels. Google Groups are standard for most of the research teams that are involved with N3C. And in case you didn't have enough Zoom meetings, we've got lots of those. You can check out the N3C calendar for all of the regular meetings that you can potentially check out and interact with other researchers on. So now I think that it helps to get a sense of the various teams and working groups that are a part of N3C. And I put this unofficial sort of mind map together of how I tend to think of N3C. And so this is unofficial in the sense that I created it out of, thin air, and it's not been officially reviewed by anyone and possibly doesn't even officially represent segments of N3C, though some parts of it do. For example, the 5 boxes here are what were originally set up for N3C as quote unquote work streams. The idea being that, we're going to have a work stream of various folks who are doing the collaborative analytics that are the important research of N3C. But there's also going to be a work stream of folks who are going to be working with data partners and dealing with governance issues and making sure that nobody goes to jail by accidentally violating HIPAA, stuff of that nature. There's a work stream of people who help with the phenotype and the data acquisition, sort of defining what data it is that makes it into N3C and how that happens. And there's a work stream of folks who deal with the data ingestion and harmonization, sort of making it all into one cohesive whole. And there's a work stream working on that synthetic data, including validating whether or not the synthetic data accurately represents the original data. Underneath these work streams, we have some interesting teams and committees and things of this nature. So under the data partnership and governance, for example, we have a publications committee who sort of put together processes for what folks should do if they want to publish on this data. We do request that folks sort of put information about their publications in a centralized location so that we can reference them and that other people know what's being worked on. Project management and administration is sort of like one of the teams underneath the data partnership and governance. Synthetic validation group we mentioned. And then of course there are the projects, and the research projects themselves live under the collaborative analytics workstream. So here, for example, this is a completely made up example of a research project that I came up with. Maybe somebody's interested in looking at heart disease and COVID-19 outcomes. But probably the most interesting thing that happens under the collaborative analytics label are what are known as domain teams. N3C has sort of organized various groups of folks under topical domain teams so that research projects with similar topics can coordinate with each other and share information. So for example, the diabetes and obesity domain team might have a research project associated with it. The immunocompromised and immunosuppressed domain team might have multiple research projects associated with it. One of which looking at a cohort of HIV patients, and another one looking at a cohort of patients with autoimmune skin disorders. And the idea here being that by organizing under a domain team, these various research groups can share information that would be relevant to each other much more fluidly. Not all domain teams are focused on sort of like a clinical topic. We do have other kinds of domain teams, which are called the cross-cutting domain teams. So for example, there's a domain team looking at machine learning approaches as applied to this data. Domain team looking at bringing in genomic data as applied to these data. And these cross-cutting domain teams also, we hope, interact with the clinical domain teams to get this information generally spread throughout N3C. Underneath, I think a little bit, both the phenotype and data acquisition and data ingestion and harmonization work streams are a group of what we call data liaisons. And data liaisons are the folks who know the data the best because they're the ones who work with it and fix it up. And the nice thing about domain teams is that the data liaisons support the domain teams as well as the project management and admin team. So there's really a benefit to sort of, if you're working with a domain team or you're working with a research project, seeing if there's a domain team that matches your proposed research project, because you'll get access to the other projects that are doing similar things. You'll be able to share tips and tricks, potentially code and stuff like that. And as part of the domain teams, N3C sort of makes official support for domain teams from the data liaisons for questions about the data, or from the project management team for things like helping with calendaring and stuff like that. So there's a definite benefit to sort of plugging into the domain team architecture and not completely going it alone as a research project. So this is my last slide. That's about it. I think, you know, if you're just getting started with N3C, you might be asking, what's next? What should I do? If you haven't, do go and register with N3C. The page here sort of includes instructions on how to finish that registration process. And when you check the I would like to access the data enclave, that will put your registration into a queue, and then someone will verify that you are covered by a DOA, probably by your home institution. And once that happens, you'll be able to access the enclave. So once you do get access to the enclave, go ahead and log in, browse around, especially that training section and the various resources. And don't forget that we have an orientation session B next week, where we'll introduce some analysis techniques and tools for working with the N3C data in the enclave. And that does it for me for now.